Everyone thinks artificial intelligence is just about predicting the next word, a software trend that might have peaked in 2024. But the data points to an impending trillion-dollar industrial mobilization and a rapid intelligence explosion. And if that is true, then the entire global balance of power will decisively shift within the next 36 months.
Right. And we have to look past the mainstream noise right now because what is happening behind closed doors? I mean, it's a fundamental reordering of global infrastructure. Markets and mainstream analysts are just completely missing the physical reality of this shift.
Because they treat it like a software update.
Exactly. They treat it like SaaS. But we are not talking about software updates. We are watching data center cluster plans scale at a velocity that completely defies traditional corporate finance.
Yeah, I mean, the baseline just shifted, right? From
Yeah.
$10 billion clusters to $100 billion clusters.
It did. And we are rapidly approaching the planning phases for $1 trillion server clusters. So the people who stand to lose the most in this transition are the pundits, the analysts looking at standard economic indicators. They are willfully blind to these specific exponential trend lines.
They think this is just another cloud computing wave, just another boom.
Right. But the only people who actually benefit right now are a handful of individuals with genuine situational awareness, the people actively building this technology, and, more dangerously, authoritarian state actors who recognize the strategic value of this transition and are quietly positioning themselves to steal it.
Because the hidden bottleneck here is not algorithmic. It's not about who has the smartest coders anymore, is it?
No, not at all. The bottleneck is purely physical. It is securing gigawatt-level power contracts. It's manufacturing industrial voltage transformers. And the timeline we are looking at is absolute, meaning based on the current scaling curves, by 2025 or 2026, we are looking at machines that will comprehensively outpace the cognitive capabilities of college graduates.
By the end, the important question is not whether AGI is possible. It is whether the free world can secure it before an authoritarian state does. But if you are listening to this on your commute or, while you're working, you might be thinking this sounds like science fiction.
Sure. Sounds crazy.
It does. So to understand how we get to that critical point of national security, we first have to examine the massive perceptual disconnect happening right now, specifically centered in San Francisco. There is just this massive canyon between what the public believes AI is and the reality accepted inside the top AI labs.
Yeah, it's actually one of the most striking contradictions in modern technology. Because on one hand, you have major financial institutions, analysts evaluating companies like NVIDIA, seriously publishing reports arguing that 2024 might be the peak of the AI hype cycle.
Right. You have mainstream tech journalists dismissing the underlying technology as business as usual, framing it as just a sophisticated autocomplete that hallucinates facts.
Exactly. At best, the broader consensus is willing to entertain that this is an internet-scale shift. A big deal, sure, but something that will take, 20 years to fully integrate into the economy.
But if you step inside the leading frontier labs in San Francisco, the atmosphere is entirely different, isn't it?
It is entirely different. The researchers there are not operating on a trajectory that the outside world even acknowledges. They are not looking at an S-curve that is about to plateau. They're looking at a vertical climb.
See, I am looking at these same reports, and I have to admit, it is incredibly easy to be skeptical of the Silicon Valley narrative. I mean, if we look at the history of the tech industry, this insular world-building rhetoric sounds exactly like the dot-com bubble.
Or the autonomous vehicle hype in 2016.
Yes. Or even the recent crypto boom. People constantly mistake the beginning of a paradigm shift for a trend that will just scale infinitely without ever hitting the friction of diminishing returns.
That is the default rational response.
Right, because when you have a group of highly paid engineers living in an echo chamber working 90-hour weeks, it seems entirely plausible that they have just collectively convinced themselves they are building the most important thing in the history of humanity.
It's the safe bet to assume they're just hyping their own book. But relying on that historical skepticism misses the fundamental empirical dynamic driving this specific technology. We are talking about a remarkably small group of people.
How small?
Perhaps a few hundred individuals, mostly concentrated in a few square miles of San Francisco. And they possess what we need to call situational awareness. The burden of knowing what they know is immense, and it really isolates them.
Because just 3 or 4 years ago, these exact same people were derided as crazy by their own peers, right, in mainstream computer science.
Yes, but they chose to trust the trend lines. They looked at the mathematical curves of compute scaling and algorithmic efficiency, plotted them on a log linear graph, and they correctly predicted the massive leaps in AI capabilities of the past few years.
Precisely when the broader academic community thought those leaps were impossible.
Exactly. They aren't operating on hype, and they aren't operating on vibes. They are operating on a relentless empirical extrapolation.
So the obvious conclusion is wrong. Mainstream society thinks the AI curve is flattening out, that we've reached the limit of what chatbots can do, but the trend lines point to an explosive vertical climb.
They do.
And to actually understand what that climb looks like, we cannot just use vague terms like smarter. We have to drive this analysis into the hard math. We have to look at the orders of magnitude.
Right, the OOMs.
Yeah. So if we break down the jump from GPT-2 to GPT-4 and frame it in human developmental terms, we essentially went from a preschooler's cognitive ability, barely able to string coherent sentences together without losing the plot, to a smart high schooler's ability.
A high schooler capable of passing the bar exam and writing complex code.
Exactly. And that profound leap happened in just 4 years.
And we really must emphasize that this leap was not magic. It was not a sudden stroke of genius or a lucky breakthrough. It was math. It was driven by specific orders of magnitude, or OOMs, of progress.
Let's define that. When we talk about an OM in this context, what are we actually saying?
We need to be very clear. An order of magnitude is a 10x multiplier. It is not a percentage increase. It is an exponential jump.
Right. 10 times the scale.
Exactly. So to understand the mechanics of the next qualitative leap, the one expected by 2027, you have to look at the 3 distinct pillars of scaling that are compounding simultaneously right now. First, you have raw compute.
The actual physical hardware.
Yes, the sheer volume of physical processing power, the thousands of GPUs being thrown at these training runs, that is growing at roughly 0.5 OOMs per year.
So that means the physical hardware power is roughly tripling every 12 months?
Correct. Second, you have algorithmic efficiencies, the software architecture itself, the way the neural network learns from the data. That is getting better at utilizing the compute, and that's also growing at roughly 0.5 OOMs per year.
So when you combine those two factors, you are compounding progress at a staggering exponential rate.
But the third pillar is what turns a smart software program into an independent actor: unhobbling gains.
Let's break down unhobbling, because we aren't just talking about making the model faster, are we? We are talking about unlocking the constraints of the system. It's almost like giving a brain a pair of hands.
That is the perfect way to visualize it. Unhobbling is the crucial transition from a passive chatbot to an active, autonomous agent.
Because a passive chatbot just sits there, it waits for you to type a prompt, spits out a static response, and then basically forgets you exist.
Right. Unhobbling means giving that underlying intelligence a persistent memory. It means giving it a scratch pad for an internal monologue so it can literally think step by step before it answers.
And it means giving it direct access to a web browser, to a terminal window, to coding environments.
Exactly. You are taking a disembodied intelligence and giving it the ability to reason, use tools, and execute complex multi-step workflows over long time horizons.
So when you dwell on the math of these 3 pillars, compounding compute, algorithms, and unhobbling, the implications are mathematically unavoidable.
Consistent compounding at these OOMs guarantees another qualitative jump of the exact same relative size as that preschooler to high schooler leap.
Yeah.
Except this time, the jump starts at the high schooler level.
Right. By 2027, the math guarantees we cross the threshold to AGI, artificial general intelligence.
And that sounds like a technical detail.
It is not. If you are a knowledge worker, if you spend your day in front of a screen analyzing data, writing reports, or managing logistics, this is the most critical reality you can internalize.
Because the leap from a smart high schooler to a machine that systematically outpaces college graduates fundamentally breaks current white-collar labor assumptions.
Completely. But if this intelligence explosion is a mathematical certainty, then the only thing that can actually slow it down is not software. It is physics.
Yes. Where do you even find the electricity to plug this in?
Which brings us to the terrifying scale of the capital being deployed. Every 6 months, another zero is being added to the boardroom plans of these tech giants. We're watching capital deployment scale from 10 billion to 100 billion, straight to $1 trillion.
This is exactly where the story shifts from software engineering to raw, hard infrastructure. The fierce, behind-the-scenes scramble happening at this very moment has absolutely nothing to do with writing Python code or optimizing neural networks.
It is an unseen industrial mobilization.
It is. These companies have realized that the limiting factor for AGI is the physical world. It is about securing every available power contract, every megawatt of available energy generation for the rest of the decade.
American big business is gearing up to pour trillions of dollars into physical concrete, steel, and copper.
Right.
I want to translate those numbers into reality for you, the listener, because $1 trillion is a number so large the human brain kind of just glazes over it. What does $1 trillion data center cluster actually require from the physical world?
It's massive.
Right. If we step out of the pristine San Francisco labs and look at the American power grid, what does this demand actually look like?
It requires a mobilization of American industrial might that we have not seen since the height of the Cold War, or perhaps the Apollo program, but funded entirely by private enterprise. We have to look at the specific geography of this build-out.
It spans the entire country, doesn't it?
It does. From the shale fields of Pennsylvania to the vast solar farms of Nevada. To feed hundreds of millions of hunting GPUs, American electricity production must grow by tens of percent. We're not just plugging in more servers. We are fundamentally altering the energy stakes of the entire nation.
To give a sense of scale, a single modern AI data center can require a gigawatt of power.
Yes, and a gigawatt is roughly the output of an entire commercial nuclear reactor. It is enough power to run a major city like San Francisco.
Now imagine trying to build clusters that require 3, 5, or 10 gigawatts.
You are talking about entire power plants. Massive arrays of specialized voltage transformers, which currently have a supply chain lead time of 3 to 4 years, by the way, and vast upgrades to the energy grid itself.
And all of this is being contracted and secured right now, isn't it?
Yeah.
Quietly, behind NDAs.
Exactly, to ensure the compute scaling does not hit a physical wall.
The bottleneck is not the model. It is the system around the model. It is the raw physics of generating enough electricity, moving that electricity, and then cooling hundreds of thousands of ships running at maximum thermal capacity.
And this physical reality raises an assumption that desperately needs to be challenged.
Which is?
Most people, when they hear about AGI, assume that even if we hit this 2027 milestone, even if we reach human-level intelligence, the progress will naturally stabilize. There is this deeply ingrained assumption of a natural human ceiling.
And that assumption is perhaps the single most dangerous misunderstanding of this entire technological arc.
Completely. Progress will absolutely not stop at human-level parity. The mechanics of what happens the day after we achieve AGI revolve around a concept called recursive self-improvement.
Walk us through that. Think about the labor force that builds these models today. It is a few thousand brilliant human researchers.
Right. And they need to sleep. They get distracted. They work 8 to 12 hours a day. But once you build a machine that outpaces a top-tier college graduate or a senior engineer, you do not just use it to write marketing emails.
Or summarize legal documents.
Exactly. You deploy hundreds of millions of these automated AGI agents to do the one thing that matters most: automate AI research itself. You replace the human researchers who built the system with the system itself.
You create a closed-loop feedback cycle. The system analyzes its own architecture, finds efficiencies, and writes the code to improve itself, which makes it smarter, which allows it to improve its architecture even faster.
It's exponential.
I want to emphasize how jarring this is. We are talking about an intelligence engineering its own successor.
And the terrifying math of this explosion is what researchers call time compression. Historically, as we discussed, achieving 5 or more orders of magnitude in algorithmic progress took a full decade of intensive human labor, trial, and error.
Right. From the early deep learning days to now.
Yes, but when you have hundreds of millions of automated, tireless AGI researchers working at machine speed, they are running 24 hours a day, simultaneously testing millions of coding hypotheses without ever needing to rest.
So that entire decade of algorithmic progress is compressed.
It will happen in a single year, or potentially even less.
Let's translate what that time compression actually means for society. It means we go from human-level intelligence to vastly superhuman systems almost overnight.
There is no gradual acclimatization period.
None. Not for the economy, not for governments. We don't get 5 years to adjust regulations or figure out universal basic income. The power and the peril become absolute, essentially in the blink of an eye.
Which fundamentally changes the threat model.
And that creates a very different kind of risk, because if this technology is quite literally the most powerful economic and military engine in human history, the immediate urgent question is, how is it being protected?
And the answer to that brings us to the security failure of the frontier labs, the silver platter.
It is a harsh, almost unbelievable reality to confront. But the nation's leading AI labs currently treat security as a secondary or even tertiary afterthought.
It's staggering. You have the most valuable intellectual property ever created, the key algorithmic secrets for AGI, sitting in environments that are fundamentally insecure.
Right.
As it stands today, given the known capabilities of foreign intelligence services, these labs are basically handing the keys to AGI directly to the Chinese Communist Party on a silver platter.
See, I am struggling to understand the security aspect. Let's unpack what they actually need to secure. The weight of the weights, we are talking about the neural network weights.
Yeah.
But for a listener who isn't a machine learning engineer, what is a weight and why is it so incredibly difficult to secure?
Yep.
Because if I am the US government building a nuclear submarine, the uranium and the blueprints are physically guarded by the military. But here, we are talking about software. Aren't we basically asking a group of 24-year-old coders in San Francisco to outsmart the digital espionage wing of foreign militaries?
That is exactly the mismatch. When we talk about model weights, we are talking about the actual trained parameters of the neural network.
Yeah.
After you spend $1 billion in months of compute time feeding data through the model, what you are left with is a massive matrix of numbers, floating point numbers. These numbers represent the brain of the AI. That is the weight.
So it's just data?
Yes, and the terrifying part is that these weights are just digital files. They might be hundreds of gigabytes or even a few terabytes, but they can be copied. They can be slipped onto a standard high-capacity USB thumb drive.
Or they can be exfiltrated silently over a network connection if a bad actor gets access to the server cluster.
Precisely. Unlike a nuclear weapon, which requires enriching physical uranium with massive centrifuges, stealing an AGI just requires stealing the digital file containing the weights.
So why are the smartest people in the world failing at basic operational security? If they have the intense situational awareness to predict the algorithmic scaling of OOMs over a 5-year horizon, how do they not have the situational awareness to lock down their own server racks?
Because human behavior is driven by incentives. The immense off-track effort required to secure AGI secrets and model weights against highly sophisticated state actors. It is completely counter to the culture and the DNA of a Silicon Valley startup.
They are built to move fast and break things.
Exactly. The incentives in these labs have been entirely relentlessly focused on scaling, on pushing the capability frontier, on shipping the next major model release to secure the next multi-billion-dollar funding round.
They are optimized for speed and open collaboration. They're absolutely not built for the grim realities of national security and state-sponsored espionage.
No, because defending against a nation-state's intelligence apparatus requires a level of operational security that is deeply painful. It requires air-gapping servers, meaning they have absolutely no physical connection to the outside internet.
And it requires systemic lockdowns, intense background checks, extreme compartmentalization of information.
All of that fundamentally slows down the rapid iteration cycle these companies rely on to survive. So they just haven't done it.
This is where the story gets uncomfortable. Because the threat isn't just foreign adversaries infiltrating the labs to steal weights, it's the technology itself.
Right.
Let's say you do build a perfect fortress. You air-gap the servers, you keep the weights secure. You still have to deal with the system you've built inside the fortress. Which brings us to the core alignment problem, what the industry calls superalignment.
The superalignment crisis is the solvable but currently unsolved problem at the absolute center of this entire endeavor. Reliably controlling AI systems that are vastly smarter than we are remains an unsolved technical and mathematical problem.
We know how to steer current models, roughly.
Roughly, yeah. We use techniques like reinforcement learning from human feedback. Basically, humans rating the AI's answers to teach it what we want. But the techniques we use today, mathematically, do not scale to superintelligence.
Because how do you reward a model for a good answer when the model is so smart, humans can't even understand its work?
You can't.
If an AGI writes 1 million lines of code to solve a theoretical physics problem, no human evaluator can read that code to check if it's safe, or if it contains hidden backdoors.
Precisely the issue. If you cannot evaluate the output, you cannot control the optimization process. And if you layer this unresolved alignment problem on top of the time compression we discussed earlier, the fragility of this dynamic becomes extreme.
If an intelligence explosion compresses 10 years of human-level progress into a single year of automated machine progress, the window of time humanity has to solve the alignment problem shrinks effectively to zero.
We are building the engine of the rocket faster than we are designing the steering wheel, and suddenly the vehicle is going to accelerate to Mach 10.
Things could easily go off the rails, and we have to be absolutely clear about the stakes here. In the context of superintelligence, failure doesn't mean a bad product launch or a drop in quarterly revenue. Failure means catastrophic self-destruction.
Unaligned superintelligence is an existential threat.
And this is where you have to zoom out to the macro level to fully grasp the geopolitical forces holding this all together. Superintelligence provides a decisive, unbeatable economic and military advantage.
It is the ultimate strategic high ground of the 21st century.
Uh-huh.
And we must acknowledge that China is not out of this game.
While the U.S. currently leads in algorithmic design, China has massive industrial capacity.
Right. They have state-directed resources and a highly capable intelligence apparatus actively targeting these unsecured U.S. labs. In this race, the very survival of the free world is at stake.
It is an all-out race with authoritarian powers to maintain preeminence. If we are lucky, it remains a technological and economic race. If we are unlucky, the desperation to secure or deny this technology escalates into an all-out war.
It's a very precarious balance.
Let's trace the inevitable conclusion of these forces. You have trillion-dollar physical infrastructure being built across the American landscape. You have an impending intelligence explosion guaranteed by the math of OOMs. You have massive security vulnerabilities in the labs, an unsolved alignment crisis, and authoritarian states racing to capture the technology. What happens when the United States government finally wakes up and realizes what is actually being built in San Francisco?
This is the endgame of the entire narrative. By 2027 or 2028, the U.S. government will inevitably wake from its slumber.
They will have to.
They will. The intelligence community and the Department of Defense will look at the capability curves, they will look at the power grid demands, and the national security state will intervene. This intervention marks the definitive end of the startup era for AI.
The era of a few dozen engineers in a San Francisco open plan office drinking kombucha and changing the world comes to a hard, decisive stop.
Completely.
Huh.
Because no private startup can handle superintelligence. The security requirements to defend against state actors, the geopolitical implications of possessing the tech, the sheer scale of the power dynamics, it fundamentally outgrows private enterprise.
The endgame will not happen in a commercial data center. It will be centralized in a SCIF.
SCIS, yeah.
And for the listener, SCIF is a sensitive compartmented information facility. It's a military-grade room or building designed to prevent any electronic surveillance or data leakage. No cell phones, no outside internet, heavily guarded.
The development of AGI will move from private labs into a massive, classified government AGI project. It will be federalized.
It is the Manhattan Project of the 21st century. The handful of engineers in San Francisco today who possess this situational awareness, who are looking at these trend lines, they are the modern equivalents of Leo Szilard, J. Robert Oppenheimer, and Edward Teller.
They are looking at the math, they know what the physics will permit, and they know the sheer magnitude of the mine that is about to be built.
And they know that whoever builds it first and secures it dictates the future of the world.
We are standing at the absolute precipice of this intelligence explosion. And right now, the entire trajectory of human history is being guided by just a few hundred people who chose to trust the trend lines when everyone else looked away.
So here is the real question. As we approach 2027, what breaks first, the U.S. power grid trying to feed the trillion-dollar clusters, the security perimeters of the AI labs, the alignment algorithms holding the intelligence explosion together, or the geopolitical balance between the free world and authoritarian powers?
The underlying math does not care about our preparedness. The compounding will continue until it hits a hard physical limit or triggers a systemic intervention.
The AI race will not be won by the companies with the smartest chatbots. It will be won by the nation-states that mobilize their industrial might fast enough to harness superintelligence. The future will not arrive evenly. It will arrive wherever intelligence has the fewest bottlenecks.